hello, it's me again. Okay, we're still working with function. This is the second lesson. Okay, we're on page 87, exercise 3. And now we're looking at something a little bit more difficult. So we're given a function. We've got the inputs, we've got the outputs, the y's, but we don't know what the rule is. We're trying to work out the rule. Okay, so it's a little bit more difficult. Okay, now let's have a look at, the way to start is to look at the output numbers. Okay, so we've got 4, 9, 14, 19. 4, 9, 14, 19. That should remind you something. Okay, remember what we've done before we got into function. We looked at sequences. Well, this is a sequence of number. 4, 9, 14, 19. The next number will be, well, that won't get it, 24. Okay, so what's the name of this sequence? Let me show you. That is arithmetic sequence. Okay, linear. Okay, it goes up with the same amount. How much does it go by? Let's have a look. From here to here, it goes by 5. Goes up by 5. Goes up by 5. Okay, so if you remember that, then you should be able to write down the rule. How do we write the rule? Just like we wrote the rule to find the nth term in linear sequences. It's the same thing, but instead of n, we've got an x. What does that mean? Okay, so y is going to be something to do with x. Just like we had before, we were looking at linear sequences. We looked at the number it goes up by, and we time it by n. Now we're going to time it by x. So it's 5x. Remember, there was one more thing we had to add at the linear sequences, and that's a correction term. What does that mean? Okay, let's see if this is by itself all right. Okay, y equals 5x. If I take x equal 1, okay, so y equal 5 times 1, that's going to be equal to, okay, that will be equal to 5. But is the output of 1 5? No, it's 4. So what do? We have to, how do we go from 5 to 4? Exactly, we minus 1. Okay, so we're going to minus 1, and then we get a 4. But that minus 1, we not need to add to the rule. So the rule is going to be 5x minus 1. That's it. Okay, so that's the rule. Now let's just check it a couple more times to make sure we didn't do a mistake. Okay, so we'll look at what about when x is equal to. It's going to be 5 times 2, and we're not forgetting minus 1. 5 times 2 is 10. Minus 1 is 9. Ooh, works. Okay, what about 3? Okay, y equals 5 times 3 minus 1. 15 minus 1 is 14. Fantastic, it works. Okay, so that was quite an easy example. What I'd like to do is one more difficult example. Okay, right. So yeah, just write it down. Pause me, write it down. Thank you. That was very quick. Well done, writing so quick. Okay. Right, and we're going to do another example. Okay. This example, I think I might have even given that to you as homework. So here we go. I gave you one. Help you with your homework here. Okay. So these are the inputs. The outputs are going to be this mess here. Minus 5, minus 8, minus 11, minus 29. Okay, so where do we start? Correct, I start with the output. So, from minus 5 to minus 8, this time I actually have to minus, take away a number, okay? It will be minus 3. Here again, minus 8 to 11, minus 11, minus 3. From minus 1 to minus 29, that's not minus 3. It's like minus 18 or something. So what's going on here? There's a problem. In fact, there's two problems. Let's start looking at the first problem. I'm looking at the input. I've got minus 2, minus 3, minus 4. Okay, they're all separated by 1. But now I've got minus 10, so there's a big jump here. And that's why it didn't go up or down by the same amount, because I've got that minus 10. So the first thing I need to look at, because sometimes we're going to try and trick you guys. Sorry about that. Okay? The first thing you need to look, before you're even looking at the amount of that the output going up or down by, you need to make sure you're looking at a list of numbers in the input that are numbers one after the other. There's a difference of 1 between them. So minus 2, minus 3, minus 4, they're separated by 1, so that will work. But just then forget the minus 10, that cannot help you. You can only do this method if you got numbers that are consecutive numbers. That's the number, that's the word I'm looking for, consecutive number. Okay, so that is fine. But is it fine? Okay, is -3 one above -2 and -4 one above -3? Because remember before it went up 1, 2, 3, 4. So no, even here it's actually a bit of a problem because it's going down, it's not going up. So I will make a mistake if I carry on like that. So in cases like that, what I suggest you to do is to rewrite the whole system again. So because what's the smallest number here really is -10. So we're going to put -10 there, and then -4, -3, -2. I'm basically rearranging the input number so they will go up by 1. Okay, not down. Okay, then I'll copy that again. Alright, and now I have to make sure I copy the output in the same way. So -10 belongs to -29, -4 belongs to -11, -3 belongs to -8, and -2 belongs to -5. Now I'm going to choose the 3 consecutive numbers. In other words, I'm not looking at -10. Okay? And now I'm looking at these 3 outputs. Now that is actually going up by 3. Going up by 3. So it's +3. If I carried on this way, I would get the wrong answer. Okay? So the rule will be, okay, I've got 3, so it'll be 3x plus, remember, there has to be a correction term. Okay? How will I find the correction term? Can I write a little bit below that? Little bit. Okay? If I take x equal -4, I'm going to have 3 times -4, which is, what is 3 times -4? Okay? It's -12. -12, but the answer is -11. How do I go from -12 to -11? I plus 1. So I need to plus 1. That will give me -11, and that works. So I have to also have the same correction term in the rule. The rule will be y equal 3x plus 1. Okay? And I'll let you check to see that the other ones work as well. Okay? Guys, good luck, and I'll see you a little bit later.